friends, this is Latha Sahu and welcome to my channel Latha Study Corner. Today we are going to discuss very important questions coming mostly in the CBSE 10th class exam. So let's see. The question is, prove that root 5 is an irrational number. You can see friends, this question mostly coming in CBSE 10th class and now AP board also, already CBSE 2019 I mentioned. So here you have to prove root 5 is an irrational number. Okay, so you can prove this one by two methods. Two methods are there. One is by contradiction method and second is by division method. So by finding the square root of 5, we will get a non-terminating decimal. So as a non-terminating decimal, so it's an irrational number. So by division method also we can prove that root 5 is an irrational number. Here we are going to prove root 5 is an irrational number by contradiction method. Clear? So let us know what is an irrational number. A number whose square is a negative number is an irrational number. So here we will prove that root 5 is an irrational number by contradiction method. So means contradiction method means we will not consider it's an irrational number, we will consider it's a rational number. So root 5 is a rational number, we will assume this one. So as a rational number is always expressed in the form of p by q. So root 5 is equal to p by q. A rational number always expressed in the form of p by q, where p and q both are integers. Q is not 0, the denominator is not 0. And next is what? P and Q are not having common factors. Okay friends, now squaring both sides. When we square both sides, we will get 5. Root 5 whole square is equal to 5. Is it? Root 5 into root 5 is equal to 5. Is equal to p square by q square. Now we will do cross multiplication, and when we do cross multiplication, we will get p square is equal to 5 q square. So here we can see p square is equal to 5 q square. It means p square is a multiple of 5. It means p is a multiple of 5. So let it equation number 1. Clear? So here friends, you can see p square is a multiple of 5. So p also will be multiple of 5. That is our equation 1. Now let us consider p is equal to 5m. Why? Because as p is a multiple of 5, so we will take p is equal to 5m, and this one we will substitute in this equation. Okay. So here what is the equation? P square is equal to 5q square. Here we will substitute p is equal to 5m. So 5 1 ja, 5 5 ja, it became 5m square equal to q square. So here you can see friends, q square equal to 5m square. It means q square is a multiple of 5. So here we can see friend, we have considered p is equal to 5m as p is a multiple of 5. And what is our first equation? P square equal to 5q square. So p square equal to 5q square. In place of p, we substituted 5m. So 5m whole square is equal to 5q square. 5m whole square is 5m into 5m, that is 25m square equal to 5 square. Now 5 1 ja, 5 5 ja, cancel. So here we got 5m square is equal to q square. So again we got q square equal to 5m square. It means q square is a multiple of 5. Q also multiple of 5. So this is our second equation. According to the first equation and second equation, p is multiple of 5. Q also multiple of 5. It means P and Q both are having common factor. But what we consider here, you can see root 5 is equal to P by Q. P and Q both are integer, Q is not 0 and P and Q are not having common factors. But here as P and Q both are multiple of 5, it means P and Q both are having common factors. Means our assumption is wrong. What we assume? We assume that root 5 is a rational number. So our assumption is wrong. Root 5 is not a rational number. Root 5 is a irrational number. So once again friends, we can recall, here we have to prove root 5 is an irrational number. So we will consider root 5 is a rational number, that is contradiction method. So as rational number is expressed in P by Q form, so root 5 equal to P by Q, P and Q both are integers, denominator Q is not 0, P and Q, that is numerator and denominator, are not having any common factors. So what we will do? Squaring both sides, root 5 whole square equal to P by Q whole square. We got 5 is equal to P square by Q square. Cross multiplication, P square equal to 5Q square. As P square equal to 5Q square, it means P square is a multiple of 5, and if P square is a multiple of 5, definitely P is also multiple of 5, that is equation number 1. Now we will consider, as P is a multiple of 5, we will consider let P is equal to 5m. We will take one more variable, 5m. So according to the first equation, P square equal to 5 square, P square equal to 5 square, and we have considered P equal to 5m. This 5m we will substitute here. So 5m whole square equal to 5q square. 5m whole square is 5m into 5m, 25m square equal to 5q square. We cancel 5 1 ja, 5 5 ja, and we got 5m square equal to q square. So as q square is equal to 5m square, q square is a multiple of 5. So q also multiple of 5. Now we can see according to equation number 1 and 2, P is a multiple of 5, Q also multiple of 5. It means P and Q both are having common factors, but our assumption is what? P and Q are not having common factors. So our assumption is wrong, and it means root 5 is an irrational number. So friends, you can visit playlist of my channel. There you can find the basics of different maths contents. You can prefer that all for your exams. So here we are going to see the next question. Prove that 2 plus root 3 is an irrational number. You can see friends, this question also came already in the CBSE 2018. This question also we are going to prove by the contradiction method. Okay, so what we will do? We will consider 2 plus root 3 is a rational number. So as 2 plus root 3 is a rational number, it is equal to P by Q, where P and Q both are integers. The denominator Q is not equal to 0, and P and Q both are co-primes. So what are co-primes? Means the two numbers are said to be co-primes if they don't have any common factors. So P and Q, the numerator and denominator, both are having no common factors. Now 2 plus root 3 equal to P by Q. Root 3 is equal to what? We will shift to in the right side. So P by Q minus 2. Now take the LCM. So here we got P minus 2Q by Q is equal to root 3. Now you can see friends, right side, P minus 2Q is an integer. P minus 2Q is an integer, whereas Q, the denominator, is also an integer. It means P minus 2Q by Q is a rational number, whereas the LHS root 3 is a irrational number. So which contradicts our supposition. What we consider 2 plus root 3 is a rational number, but here what we got, the RHS is a rational number and the LHS root 3 is an irrational number. That contradicts our supposition. It means 2 plus root 3 is not a rational number, it's an irrational number. So friends, you can see such an important question, such a easily we solved. Now this type of question mostly is coming in the exams. So this is for today. Thanks for watching me. Subscribe my channel, and if you like my videos, like it and share with your friends in Facebook and WhatsApp. Thanks for watching. Thank you.